So, nearly 50 years. Think about that, almost half a century since humans last set foot on the moon.
It's incredible when you put it like that.
Yeah, but now, April 24th, 2025, there's this huge energy, this real buzz around NASA's Artemis program again. It feels different this time.
It absolutely does. More than just nostalgia, it feels like a genuine new beginning for lunar exploration. And that's exactly what we're digging into today.
You want to get a clear view of where Artemis is right now, right?
Precisely. What are the big goals? I mean, landing the first woman and the first person of color on the moon, that's historic.
Absolutely. And setting up shop there long term.
Yes, establishing a sustainable presence. And crucially, how this all serves as a stepping stone, towards the ultimate goal, Mars.
Right. And for you listening, maybe you want the key info on this huge topic fast, without wading through everything. Well, consider this your shortcut. We're boiling it down.
That's the plan. Get you the essentials.
Okay, so let's kick things off. Where have we been recently with this lunar push? What's happened so far?
Well, the big foundation piece was Artemis I back in 2022. That was the uncrewed mission.
Ah, yes, the Orion capsule flight.
Exactly. It went around the moon, came back safely. That wasn't just a test flight. It was a critical proof of concept, validating all the core systems, showing we could operate again in deep space.
Like a full dress rehearsal, but without the actors yet.
You could say that. A really comprehensive systems check in the real environment. It basically paved the way for putting humans back in the picture.
Okay, so Artemis nailed the tech check. Now, 2025 is all about Artemis II, which everyone's talking about. This is where people get back on board.
That's right. Artemis II, launching this year, hopefully, is the first crewed flight of the program. Super important step.
But they're not landing yet with Artemis II, are they?
No, not landing. It's an orbital mission. The crew will fly around the moon and then head back to Earth.
So it's about testing the life support, the navigation, everything, but with a crew actually in deep space this time.
Precisely. Before you attempt a landing, you absolutely have to know all those systems work flawlessly with humans on board, far from Earth. It's that vital check: can we safely get people to the moon's vicinity and back again?
Makes sense. Prove the taxi works before you try to drop passengers off.
Something like that, yeah.
So Artemis II proves the round trip with people. Then the really big one is Artemis III, planned for 2026. That's the landing.
That is the landing. And it's not just any landing. Artemis III is aiming to make history again, putting astronauts back on the lunar surface after, well, over 50 years.
But you said it's different. This time they're not going back to the old Apollo sites.
Not at all. The target is completely new and scientifically fascinating: the lunar South Pole.
The South Pole. Wow. Okay, why there? What's special about the South Pole? Humans have never walked there.
Exactly. The big draw is the potential for water ice. Scientists believe there could be significant amounts trapped in permanently shadowed craters down there.
Water ice. Okay, water is useful, but is that the whole story?
Well, here's the kicker, the really game-changing part.
Yeah.
Water ice isn't just for drinking or, life support.
Right.
You can split it. Using electrolysis, you break H2O down into hydrogen and oxygen.
Hydrogen and oxygen. Wait, that's rocket fuel?
Bingo. And breathable air. So imagine the possibilities potentially refueling spacecraft on the moon, using lunar resources.
Okay, that's huge. That changes everything about how you'd operate in space long term. It's not just visiting. It's potentially setting up a cosmic gas station.
It fundamentally shifts the economics and the feasibility of sustained deep space exploration. It's a massive strategic advantage.
So Artemis is clearly about more than just planting flags again. It's practical, resource-focused. But the vision goes beyond the moon, too, right?
Yeah.
This is linked to Mars.
Oh, absolutely. The moon is, in many ways, a crucial proving ground for Mars. Think about it. Mars is the long-term objective.
So how does going to the moon help us get to Mars? What's the connection?
Well, Artemis is where we develop and really stress test the technologies, the operation strategies, and frankly, the human endurance needed for those much longer deep space missions.
Right, Mars is for a much longer trip.
Yeah.
Years, potentially.
Exactly. So on the moon, we can work on things like closed-loop life support systems, systems that recycle air and water efficiently so you don't need constant resupply from Earth. That's critical for a Mars journey.
Okay.
We need reliable power sources that can work long-term on another world. Solar power, maybe other solutions. And we need to figure out how to build and operate habitats where crews can live and work productively for months, even years, far from home, dealing with radiation, isolation.
So the moon acts as a sort of training ground, a nearby deep space lab to work out the kinks before the really long haul to Mars.
That's a great way to put it. It's our sandbox, our extreme environment test bed. We learn how to live off the land to some extent, manage complex systems, and keep crews healthy and effective, all relatively close to home before we commit to Mars.
And part of that infrastructure, that stepping stone, involves something called the Gateway. It sounds like a space station, but around the moon.
It is. The Gateway is a planned orbital outpost, a small space station in lunar orbit. It's a really ambitious but strategically vital piece of the puzzle.
Okay, so what does it do? Why put a station there?
It serves multiple purposes. It can be a staging point for missions down to the lunar surface, making landings potentially more flexible. It allows us to practice long-duration spaceflight outside Earth's protective magnetic field, which is crucial experience for Mars crews.
So like a midway point, a base camp in lunar orbit.
Sort of, yeah. And potentially a place for spacecraft assembly, refueling, repairs, scientific research. It's designed to be a hub. And importantly, it's being built with international partners.
Ah, so it's not just NASA building this whole thing alone.
Yeah.
This Artemis program is a team effort.
Very much so. It's a huge international collaboration. The European Space Agency, ESA, is a major partner. They're providing the service module for Orion, the powerhouse, essentially.
Right.
And other countries are contributing key technologies, expertise. It really highlights that space exploration, especially at this scale, is seen as a global endeavor now.
That's quite a shift. And speaking of shifts, it's not just countries involved anymore, is it? Private companies are playing a massive role.
That's perhaps one of the biggest changes from the Apollo era. Companies like SpaceX are deeply integrated.
SpaceX is building the lander for Artemis III, right? Their Starship.
That's the plan. Their Starship is selected as the human landing system. And of course, SpaceX and other companies are pushing hard on technologies relevant not just for the moon, but directly for Mars, too.
So it's this mix. Now, NASA's experience and long-term vision combined with the maybe the speed and innovation of the commercial sector.
Exactly. It's a new paradigm. Government and private industry working together towards these incredibly ambitious goals. It leverages the strengths of both.
It paints a picture of a really dynamic global effort. But beyond the hardware, the science, the collaborations, there's something more fundamental, isn't there? The inspiration factor.
Absolutely. You can't discount that. Artemis is hugely about inspiring the next generation, the kids who will become the scientists, engineers, the explorers of tomorrow. It's about pushing boundaries, that basic human drive to explore.
And NASA has that phrase, right? About not just going back, but
Returning to the moon, but this time to stay.
yes, that phrase really captures the shift in thinking.
This time to stay. That implies permanence, sustainability, not just short visits.
Exactly. It's about learning to live and work off Earth for the long haul, establishing a sustained presence, building infrastructure, using local resources.
And the ripple effects of all this, the technology developed, the science learned, the partnerships built, they go way beyond just space exploration, presumably.
Oh, undoubtedly. The advancements in life support, energy, materials, robotics, computing, they often find applications back here on Earth. And the scientific discoveries from the moon, especially the South Pole, could be profound. Plus, these international and commercial partnerships set a precedent for future large-scale projects. It really forms the bridge to Mars. So as we're here, now in the second half of 2025, with Artemis II coming up and Artemis III on the horizon, it does feel like we're right on the cusp.
The anticipation is definitely building. It feels like we're truly embarking on that next great chapter. It's not just looking back, it's the start of the journey outwards.
So pulling it all together then,
Yeah.
Artemis isn't just Apollo 2.0.
Not at all. It's much bigger. It's a strategic, long-term program building the capabilities, the tech, the experience, the infrastructure for eventually sending humans to Mars.
Powered by global teamwork and private innovation.
Exactly. Driven by some really exciting science like lunar water ice and underpinned by that powerful ambition to inspire and to make humanity, truly interplanetary.
Okay, so here's a final thought for you to chew on thinking about all this. If we do establish a sustained presence on the moon and eventually make it to Mars, what are the completely unforeseen breakthroughs, the things we can't even imagine right now, scientifically or technologically, that might come out of it all for humanity?
That's the really exciting question, isn't it? The unknown unknowns. History shows that whenever we push boundaries like this, the unexpected discoveries are often the most transformative. It's staggering to think about what might be possible.